Hello everyone. Today I will be explaining how the Brilliant Candy Factory works. There are candy factories worldwide, and the two we will be discussing today are the Ionic Factory and the Covalent Factory. The Ionic Factory specializes in cookies and the Covalent in cakes. First, I'll explain the Ionic Factory. This is where the factory takes cookie dough, which has a similar structure of sodium, so I will be explaining it in terms of sodium, and chocolate, which also has a similar structure as chlorine, so I'll be explaining it in terms of the structure of chlorine, to make the perfect cookie. The structure of sodium has 3 energy levels and 1 valence electron. Valence electrons are the electrons on the last energy level. Chlorine also has 3 energy levels but has 7 valence electrons. These two elements do a special type of bonding called ionic bonding. Ionic bonds are formed when electrons are gained or lost to form ions. Both elements want to have 8 valence electrons since that gives the best flavor, and chlorine wants 1 more electron to have 8 valence electrons since it has 7 electrons, and sodium needs 7 more electrons, but it's difficult to get 7 more electrons, so it just wants to get rid of the 1 electron it has. This means that chlorine is negative since it has 1 less electron to have the perfect amount of electrons, and it means that sodium is positive because it has 1 more electron than the perfect amount of valence electrons. So, to do this bonding, sodium has to give 1 electron to chlorine, and so now chlorine has 8 valence electrons. Sodium can get rid of the third empty energy level and will be left with 8 new valence electrons from the second energy level that it has. Next, we will talk about the covalent factory, which converts eggs, which has a similar structure as hydrogen, and chocolate, which again represents chlorine, to make the perfect cake. This is achieved through covalent bonding, which is a chemical bond that involves the sharing of electron pairs between atoms. We know that hydrogen has 1 electron but wants 2 electrons, which you can analyze from the periodic table. I will explain this to you a little later in the video. And we also know that chlorine has 7 valence electrons and wants 8 valence electrons, which we learned from the previous slide. To do covalent bonding, first we have to add all wanted electrons from both elements. That's 2 plus 8, which equals 10. Next, you add all the valence electrons that both elements have right now. That's 1 plus 7, which equals 8. Then you subtract these two numbers, which is 10 minus 8, and this gives you 2. This is the number of electrons that the two elements have to share between them. So we put these 2 electrons between H and Cl, Cl standing for chlorine. Finally, you add all the missing electrons. Hydrogen wants 2 valence electrons, and this has already been achieved. However, chlorine does not have 8 valence electrons. It only has 2, so we add 6 more electrons to make chlorine happy. Now we will be analyzing periodic tables. In a periodic table, there are groups and periods. Groups are set horizontally, ranging from 1 to 8, and they represent valence electrons. Periods are set across vertically and represent the number of energy levels. So let's look at sodium. Sodium is in group 1, period 3. This means that it has 1 valence electron and 3 shells. Moreover, the step-like line on the periodic table indicates the separation between nonmetals and metals. Metals are on the left side of the line, and nonmetals are on the right side. These are useful as they help us determine which elements do which bonds and the elements that they are compatible with. There are a few differences between the ionic bond and the covalent bond. Ionic bonds are between nonmetal and metal elements, whereas covalent bonds are between nonmetal and nonmetal elements. Another difference is that ionic bonds give or take electrons, whereas covalent bonds share electrons. Ionic bonds have positive or negative charges, but covalent bonds have no charge. They have high melting points and boiling points, which differs to covalent bonds which have low melting points and boiling points. Thank you for watching.
Created using Powtoon.